You're good in them.
Oh,
You
yes,
see
sir.
what? Are you that good in them?
Not that good, but I kind of understand them, sir.
Okay. Okay. Now, the rules of exponents. If you, okay, if you have a to the power of n times a to the power of m, what is the answer?
Isn't it a to the power of m plus n?
Perfect. Same thing if it's n divided by a to the power of n divided by a to the power of m. You will get a to the power of n minus m. Okay, then that's perfect. So, how do we go about 1.1.1? Okay. Do you know what are prime numbers?
Mhm.
Do you know what are prime numbers? Mahlatsi?
Yes.
You know what prime numbers are?
Um, prime numbers.
Yebo. Prime numbers prime numbers only have one factor. Actually, two factors. One and itself. For instance, two prime numbers. We have 2, we have 3, we have 5. What's the other one, Mahlatsi? Do you agree with 7? Umisa, do you agree with 7?
Yes, sir.
What's the other one?
11.
11. Mahlatsi, the other one, the last one. Let's just say the last one. Mahlatsi? I think she said 13, and that's correct. Okay. Now, we're gonna be using only these two in many cases. So whatever you have, you will have on the screen, you're gonna have to break it down into these two prime numbers, 2 and 3. So if you have, let's say for instance, you have 16. So if you have 16, you have to break it down into the smallest primes, which is 2 and 3. So if you have 16, for instance, okay, the first number that you have to divide with is going to be 3. If you divide by 3, can you divide 16 by 3?
No, sir.
Mahlatsi, can you?
No.
Then we move to another one. Then we replace it. Then we agree that no, we can't. So if we can't, let's try 2. If we divide 16 by 2, we get
8.
8. Okay. If we divide it by 2 again,
8 4, sir.
4. Again by 2,
8 2.
2. Then we will have 2 to 16 is actually 2 to the power of 1.
Oh. Oh.
2 to the power of 4 is how much?
16, sir.
16, yes. 1, 2, 3, 4 to the power of 4. All right. Let's take again 12. If we take 12, we will do the same thing. With 12, we have 12. The first number that you must try with is 3. Okay, 3. If we divide 12 divided by 3, we get
4, sir.
4. Then if we try 3, will it allow us?
No, sir.
Then we move to 2. We agree.
Yes, sir.
Okay, then what are we getting? We're getting 2. Then is 2 divisible by 2? Yes, it is.
Yes.
If you divide it, it's 1. It's 1. So we end it there. So we're gonna have how many 3s? We're gonna have 3 to the power of 1 times 2 to the power of, how many 2s do we have, Mahlatsi?
2.
2. This is equals to 12. So in the place of 12, that's what I'm gonna do. I'm gonna replace 16 with 2 to the power of 4. So whenever you see these exponents, you must break them down into the smallest 2 primes, 2 and 3. I don't think they'll give you problems which has the smallest prime of 5. But if it happens, I think you will apply the same principle. Okay. Is 4 a prime number?
No, sir.
Therefore, we must break it down also. We only want prime numbers. So it's going to be 2 to the power of what? Okay, let's do the same thing. 4, 2, 2, then 2, then 1. So we're going to have 2 to the power of
2.
2. Okay, that's perfect. Okay. 2 to the power of 2. Yes. Okay. Now let me put it down into perspective. We will have 16. We said it's going to be 2 to the power of 4. We agree, right?
Yes.
Then it's going to be to the power of 4, then times minus x. Okay, then we will have times 12 to the power of x plus 1. We said 12 is going to give us what?
2 to the power of 2.
Yes. Perfect. But all these to the power of x plus 1. Okay. Then we will have, underneath we will have 3 to the power of x. Do we agree that 3 is the prime number?
Yes, sir.
Okay. It's going to be to the power of minus x. Now, the second step is to apply the principle of exponents and multiplication of exponents. Now, we inside the first brackets, we only have one base, which is 4. So it's going to be very easy to multiply the exponents. So how do we multiply an exponent which is inside the bracket and the exponent outside the bracket? What are we going to get? Kumis?
Is it going to be 3x times bracket 4 bracket
No.
then?
I think you made a mistake. You just said 3x.
Oh, yeah.
Okay. 2 to the power of
4.
2 to the power of
2, sir.
4.
Is it?
Oh, okay, it's gonna be 4 times minus x. Because if you go back to the laws of exponents, you are allowed to multiply these two exponents. Do we all agree?
Yes, sir.
Therefore, this is minus x, minus 4x, sorry. Then times, we have 3 to the power of 1 times 2 to the power of 2. According to the law of exponents, we will have 3 to the power of, we are allowed to multiply the exponents in this case. The same way we did on the previous, inside the previous brackets. So we will have 1 times x, which is how much?
3.
1 times x,
1x, sir.
which is x. Mahlatsi, you agree?
Yes.
Then we will also have 1 times 1. Have you guys done a multiplication of of factors that are in brackets?
Mm-hmm.
Have you done this already?
Yes, sir.
Multiplication of binomials. Yeah, I think that's the correct term. Have you done it?
Yes,
Yes.
sir.
You know that this one will multiply that one and also multiply that one again.
Mm.
The same thing when you have 2 into x plus 1. This one will multiply that one and that one also. You agree?
Yes, sir.
So that's the principle we applied. Okay. Moving forward, we have, I think you will agree with me, and then times 2 to the power of, we will do the same principle. We'll multiply the exponents. 2 times x, 2x. And then 2 times 1 will give us 2. So we are done with the numerator. And then the denominator, Mahlatsi, what is it that is going to be? Gonna be? Then what will happen to this one? Who is?
We multiply the exponents.
Which is going to be?
Oh, negative 4x.
Negative.
4x.
Why is it 4? The exponent is how much? Is it 4?
Oh, so it's 2.
You agree?
Yes, sir.
Okay. That's what we have now. We still have to solve the numerator further, which in this case, we will have 2 to the power of minus 4x times, I want to get rid of the brackets. So do you agree that according to the laws of exponents, which we have done right here, where is it? We have done right here. We are actually reversing. Do you see that? This is the expression we have, so we have to take it back.
Mm-hmm.
Do you agree? Come on.
Yes, sir.
The same thing that we have here. So in order to break it down, we will have 3 to the power of x times 3 to the power of minus 1. Do you agree with that, Mahlatsi?
So how is it a -1?
It is a -1 because that's a -1 right there. You agree?
Yes.
Yeah, because if you multiply these two exponents, if you multiply two exponents that have the same base, you're gonna have to add the exponents. You agree? According to the laws of exponents. Mahlatsi, do you agree?
Yes.
Kumisi, you agree?
Yes, sir.
Okay. So on the next one, Mahlatsi, how do we break it down?
It's going to be
What the brackets? No, there is a bracket. Okay. So it's gonna be
2x to the power of, no, it's going to be 2 to the power of 2x
the power of 2x and
times 2 to the power of 2.
correct. Do you agree, Miss?
Yes, sir.
Okay. Now the bottom one will repeat 3 to the power of x, then times 2 to the power of minus 2x. Now from here, I think it has become very easy. I'm sure everyone can do it. Isn't it easy at this point?
You
You don't think?
okay?
Mahlatsi, what will be the next step now?
And we're going to group the like terms.
Yeah, you can use, yeah, you can say like terms. Yes. Okay. You are right. We are, but the good terminology that I wanted was we are going to add the exponents of all the numbers that have the same base. You agree?
Yes.
The first base is 2 that we're gonna evaluate. So we're gonna have 2 to the power of minus,
4x.
then plus 2x. You agree?
Yes.
Then plus 2. And then times 3 to the power of, we also, or do you think we are done? I don't think we are done with 2. Because there's how many 2's we have? We have 1, 2, 3, 4. And we only have 1, 2, 3 exponents. How do we deal with these exponents? Miss? Mahlatsi, how do we deal with an exponent which is part of the denominator? If you go back to your notes, you have to give it a minus. Minus whatever exponents you're gonna get. Do we all agree?
Yes, sir.
Because if it's a multiplication, we do what? We add the exponents. But if we are dividing, we minus the exponent. So with 3, we're gonna have x minus 1. X minus 1 minus 1 minus x. You agree?
Yes.
Okay. And the other thing that I didn't want, ne, was I could have went straight on this step, actually, this one. I could have just added. You can do that as well, but I wanted to see the principle. You could have skipped this stage, in fact, and then went straight to adding the exponents, because already we have the base of 2. You were going to arrive in the same answer. So I'm not gonna give the answer. We're gonna do the answer on the next segment, but I think you have gotten the gist of how to work around the exponents. So I'm so sorry for messing up with your time. I'm gonna try to catch up tomorrow, say after my 8 o'clock lesson. We can have, say, about 30 minutes. Then we can catch up with the time that we have lost.
Yes, sir.
Yeah, so thank you for being part of this lesson. I'll see you guys tomorrow on our physics class, which is starting at
5 o'clock.
5 o'clock, yes. And then we're also going to have an extra 30 minutes for maths, the one that I've lost today.
Yes, sir.
All right. See you guys tomorrow.
Bye.
All right.